Hello, good evening. We are from Group 7, and right now we want to present our final assignment. And we got social network analysis for the subject Big Data and Data Analytics. And we are from class MB 4611. Next. Before we present, we would like to introduce you about our group members, including Rafila Zhilal Hasanuddin. I am Putu Tanya Hapsari, Kasyfurrahmat Affendy, and Thariq Fathurrahman Ali. This is the assignment guideline that include business understanding, data crawling, data preparation, modeling, evaluation, and deployment. Next.
Okay, now it's about business understanding. The data we use comes from Instagram application user, including username, review, rating, date, version, and number of likes. This data represent the interaction and option of user towards the apps, reflection to review, star ratings, and the number of like each review received. To this data, we apply social network analysis to understand the dynamics of social relationship among user and identify interaction patterns that influence the perception of the Instagram apps. Moreover, analyzing patterns of interaction and user engagement is crucial to understand how review, rating, and likes are interconnected in shaping the community perception of the app. For instance, a low rate review with a high number of likes could indicate a common concern that needs immediate attention from developers. On the other hand, a high rate review with positive support may indicate a successful feature that is for further development. The implementation of SNA also aids in detecting user communities with similar interaction patterns by identifying this group. Developers can design more relevant and personalized communication strategies to enhance user engagement. Additionally, sentiments analysis can be applied to assess whether the majority of review reflect user satisfaction or disappointment. And furthermore, SNA can be used to detect suspicious or inauthentic review, such as spam or bots, which may harm the app's credibility. Fake review are often identified through unnatural interaction patterns, such as many review with similar text or accounts providing extreme rating without comments. Next.
Okay, so first, before we process the data, so we crawling the data fresh from Google Play Scraper. What we need to code is we should install pip. It used to install Python library or package directly from pypi or Python package index that the exclamation mark indicates that this command is executed in the terminal or shell, typically with Jupyter Notebook or Google Colab. And the second one, we should use the Google Play Scraper because we're searching the data from Google Play, and a Python library designed to automatically fetch data from the Google Play Store. And this package simplifies retrieving information such as application name, description, user views, app ratings, and number of downloads, which we search for is the data from the application that we call Instagram. Next. And for the data crawling, of course, we should use the data retrieval from various user, including username, rating, review, date, app version, and like count, and all of those data that we search from the apps, Instagram apps. And in this coding, we can see that we search for max review. The amount is 1,000 that specifies the maximum number of review to retrieve is in this case is 1000 review, and then we scrap 1000 reviews, and all reviews equal to scrape the reviews, call the scrape reviews function to fetch up to 1000 reviews from an application identified, which is Instagram. And as you can see, it's also scraping the username, review, rating, that app version, and like count. Next. Okay, so we also use this code for processing the data, review data, and also to save the data that we already crawling. So we crawling and we search for the data that we need, and we also save it. That we use several commands like reviews, sort, import pandas, up ID, and the others that explanation you can show on our presentation. Next. And for the next, we use save to file CSV, because from the data that we scraping, we need to save it and we need to import files and download it, so it would be saved in our laptop or computer that we gonna use in the next coding or the next IPNB.
Okay, now it's about data preparation. For the first, we prepare the data set and categorize it into age and nodes. Next. Okay, so we import the library function that will be used. Next. And we upload and open a local dataset that contain detailed information about nodes and age. Next. Okay, so we display data about the number of nodes and age, and thus in both dataset, the number of nodes is 993 and the number of age is 96. Next.
Okay, next, initialize the SNA function using an X grabs. In this step, the social network analysis or SNA function is initialized using an X grab. This step aims to create a network object that can be processed further. Data about nodes and edges are input into the network using the add nodes from and add edges from methods. Nodes represent user, while edges represent the relationship between them. By running print Instagram network, this dataset contains 103 nodes and 96 edges, which show the network structure and the number of connection between each user. Next. Review data of nodes and edges. In this step, a preview of data from nodes is done using NX nodes. Nodes are individual elements in the network that represent user or other entities. The nodes data is displayed full text format to provide an overview of the connected elements in the network. Next. View the edges of the network. Display edge data using the edges variable. Edges represent in the relationship between nodes. The edges data is displayed in model pairs. X, node A, node B. This indicates a direct connection between two nodes in the network. By knowing this relationship, we can identify interaction patterns within the network, such as interconnect groups or highly connected users. Next. Calculate the graph density level of the network. Graph density measure the level of relationship in the network. The higher the value, the denser the relationship between nodes in the network. In this figure, the density value of the dataset is 0.019%, which is quite low for a network with 1003 nodes and 96x. Although low this density is considered good as it allows efficient dissemination of information through key players without excessive redundancy. Next.
So for the next one, we know that we count the number of groups or community formed in the network using modularity. We can show it from the frozen set and from the number and name, which we can see the relation between the amount of like and also the person who make the review. And for this step, we used to make the community detection using modularity. Next. So for the next one, if we count for the group or the community formed in the network, there are 907, which means that the modular structure is very high because it built a lot of community from all of the data. Next. And also, for the next one, we calculate the number of group or community formed within the network using modularity, which we make to see what layout are available in this network. There are 15 data visualization that can be used, so we can make a visualization that there are 15 data visualization. And for the next part of modeling, we perform network visualization using the Kamada Kawaii layout. So from this step, we're starting to make a data visualization from the data that we scraped before. Next. So here we are, we can see about the data visualization, which I would try to explain about the interpretation. At the center of the network are nodes that are more connected to many other nodes, indicating that there are members who serve as hubs or centers of connection. Within the network, they play an important role in connecting many other members. So if we can see in the center, it's an important people, and they have a very important and connected relation to the others. And these nodes are individuals who are very active or influential in the community. They may act as a leader between groups or member with significant social roles. And we can see some nodes are at the edge of the network. You can see with a little connection to other nodes. These nodes have limited connection and fewer links to the center of the network. So if you see people in the edge of the picture, it means the connection is more it lesser than the others. And these nodes have limited connection and fewer links to the center of the network. And these peripheral nodes may represent less active members or have more specific connection to only a few individuals in the network rather than the entire community. So more far from the center, it means more limited connection to the others people. Next. Okay, so for the next, we also perform network visualization using Spring Layout, which is a different visualization than before. If we can see from next. From that modeling, we can see this visualization, which I would interpret the picture at the center of network. There are several larger and lighter color yellow nodes are visible. The larger size of the nodes indicate height between centrality, their role as a main link in network. The central nodes serve as a bridge between different parts of the network, controlling or facilitating the flow of information between different groups. The color of node indicates degree centrality or the number of direct connection each node has. Node with lighter colors have a higher degree, meaning they are directly connected to more nodes. These lighter colored nodes tend to be more influential or popular in the community. They have many direct connection which allow them to be more active and in the network. And several group or sub-community can be seen around the core of the network. This group mainly consists of nodes that are not that are more connected to each other but less connected to the nodes at the center.
Okay, for the next, we also perform network visualization using Fathurrahman layout. You can see data visualization with Fathurrahman rain gold layout. And the next, At the center of the network, there are several large nodes that are brighter in color yellow. The large node size indicates height her betweenness centrality, meaning their role as key connector and in the network. The central nodes act as bridges connecting different parts of the network, helping control or facilitate the flow of information between various groups. And the next, the color of the nodes represent degree centrality or the number or direct connection each node has. Node with brighter color, example yellow, have a higher degree, meaning they are directly connected to more nodes. And then these brighter nodes are likely to be more influential or popular within the community as they have many direct connection, allowing them to be more active in the network. And the last, several small group or sub-community can be observed around the core of the network. This group may consist of nodes that are more connect to each other but less connect to the central nodes. In the next, you can see calculating the degree centrality of each nodes. And then calculate and sort the 10 nodes that have the large degree centrality of the network. And then in the picture above, it can be seen that the nodes that have the highest number of like counts are number 1. Okay, next. Calculate and sort the top 10 nodes with the highest betweenness centrality in the network. And then in the image above, it can be seen that the nodes playing a significant role in connecting others in nodes 2. And then calculating and sorting the 10 nodes that have the large closeness centrality of the network. In the figure above, it can be seen that the node that has the greatest proximity in this Instagram network is not one with a value of 0.0738, allowing them to more quickly communicate or spread information through the network compared to others. And the last, calculate and sort the 10 nodes that have the large eigenvector centrality of the network. In the picture above, it can be seen that the nodes that have the greatest influence are node 1.
Okay. Evaluation of model result with relevant metrics. Number 1, graph density. Network density 0.0 on 0.019%. Efficient for 1003 nodes and 96 Number 2, shortest path indicates a fast communication path between nodes. Number 3, degree centrality. Node 1 is the most connects or most direct relationship. Number 4, betweenness centrality. Node 2 is the main link between groups. Number 5, closeness centrality. Node 1 has a strategic position for information distribution. Number 6, eigenvector centrality. Node 1 is the most influential in the network. Number 7, there are 907 communities format, reflecting the high level of segmentation in the network. Next. And next, the deployment application of analysis result in real business. Number 1, identify opinion leaders. Optimize Node 1 and 2 to support marketing. Number 2, community strategy. Understand the needs of the group for personalized communication. Number 3, feature enhancement. Improve the app based on user interaction patterns. Number 4, spam detection. Identify inauthentic review to maintain credibility. Number 5, information dissemination. Use strategic notes for effective campaigns. Number 6, user management and judgment. Make central notes ambassador or influencer.
So that's all from us about our final assignment presentation, and thank you so much.